I'll start recording this. Now, okay, first things first. Let's take care of the details of the final exam. Right? Syllabus. All right, final exam is circ 1080. Okay. So where circ 110 AB. When? Okay, and see final exam schedule. Final exam schedule says that our exam is at 1 o'clock. Okay. 5/2. What to bring sheet. 1 page of notes. Front and back. Pencil or pen.
Listen to your body.
Okay, publish. So I've just sent out an announcement for the final exam and its details. You should be getting that in your email shortly. You can also see it on the announcements. Everybody able to hear me just fine, or just want to make sure, right? Yes, no? Great. Okay, so last day of classes. Let's go ahead and get into this, shall we? Let's go ahead and move this window down to where we need it to go. Today, I'm going to make sure that we are going over Monte Carlo approximations, and we are going over so we're going to go over Monte Carlo approximations. We're going to go over regular expressions. Now, remember, regular expressions are one of the I plan on having, a couple of questions that are required in the first part of the exam will be a bit easier. And then the second part of the exam, where the harder questions are, you'll be able to choose from a subset of those questions. Make sense? Oh, yeah. Let's see. So what did I write down as the, okay. All right. Oh, yeah. Now, so let me go ahead and share my screen. All right. So this has been so up on top over here, this has been the, let's go with bigger questions. In the past, it has been 7 questions. Choose 5 out of 7. We may not do 5 out of 7, but 5 is definitely the most I would do. And I was trying to remember, okay, what else did I have in this list? Right? What else did I have on my wrist? Sorry, not wrist, list. And of course I remembered, because one of them was, I don't tell you. It's the mystery question. What? What is that? The mystery question basically is one of my favorite questions, because it asked you, hey, here's a thing that we haven't learned in class yet. Now you're probably thinking to yourself, Professor Rosen, that seems rather unfair to ask us something that you didn't teach us. Except that I give you all the details on how to use it on the exam. I basically say, this is something in Python. Okay, I did not go over it in class. Here's how you use it. Here's like the basic commands on how to use this. Like if it was a list, I'd say, here's how you basically add to the end of it or add to the front of it. Those kind of things. So I'll tell you how to use the operations, and then I'll say, this is a common question where we use this. So now you can you solve the problem using this? And again, that's why it's part of this kind of subset. But honestly, it's a good test of how well are you understanding. Will this code be posted in the announcements? I can do that. But it's not done yet. So, it's not done yet. So, so I'll post it at the end. All right. So now with regards to all this code, So that mystery question, that's been one. But that's basically, again, it's something built into Python. I'm not going to be making just something up like a Nord or a Wizmo or Gizmo. Just like I'm not making something up. It's going to be an actual thing that exists in Python that has a use. All right. So with regards to regular expressions in Monte Carlo, let's see. So the only thing that this practice exam doesn't have actually is a good regex question, but I have one over here. But it's the same kind of regex question I've introduced you to. But let's go over here to the other questions over here. Before we get into the big questions, let's warm up with a few more of these other questions over here. Okay. So all digits product. Given a list of numbers, right? We have a list of numbers. Return the product of all digits of all the numbers in the list. So over here, we've got 1, 2, 3, 4, 5. It gives us 120. Why? Because 1 times 2 times 3 times 4 times 5 is equal to 120. Over here, we get 0. Why? Because 1 times 0 times 2 times 0 times 5 is 0, right? Now we've got 44 times 12, so we've got 44, 12, and 3, 1, 1, 2. Notice the answer is 129. It's not multiplying all these things together. It's multiplying the individual digits. So 4 times 4 times 1 times 2 times 3 times 2. Well, that's 16 over here. That's 6 over here. So that's 12. So it's 16 times 12, and I'm sure somebody can do the math and see that that's 192. I certainly can't, not in my head, but I can with a calculator. I know, such a wonderful skill. All right. Let's go ahead and drop the definition in here. So all digits pod. So how do we do this? How do we go through digit by digit? Now, so for n in nums, right? We'll need to iterate over it. But before we do that, I always like to set up, right? I'm going to be giving back the product. I know I'm kind of doing this in reverse. Going to be giving back the product. So how do I, and the product, the main thing about a product, it's just like a running sum. The difference is that we're not adding, we're multiplying. And the identity for multiplication, so the identity for adding, right? The identity, if we're adding things up, is 0, right? Total equals 0. We start with 0 when we're adding because anything we add to 0 is going to be itself. That's what I mean by identity. Anything plus 0 is itself. On the other hand, 0, anything times 0 when you're multiplying becomes 0. What we want for the product is 1. That's the identity here. That's the only thing that's weird when you have multiplication issue, when you're multiplying, doing a running multiplication. So now it would be nice if I could just do this, right? For n in nums, product is equal to product times n, right? But that multiplies all the numbers together. It doesn't, you know, go through all the digits, right? I want to go through for each n in nums. So let's go ahead and actually make it for number in nums, right? So for each number in the list of nums, I don't want to multiply that number. I want to multiply all the digits in that number. And unfortunately, I can't just do this. For each digit in nums, sorry, in non-num, but for each digit in the number, although if you did do that on the exam, I would spare you some mercy because there is a way we can get there. There is a way we can get there, right? Which is we can do it like this. We could ostensibly do this right? We could cast that into a string right here. Or if you don't, or if that looks weird to you, what we could do, we could get this to work. That's why I'd have mercy on you. Okay. Why can't you? Because a number isn't iterable. You can't iterate over a number. A number is just a thing. It's a single thing. You can't iterate over it. Right? That's why it just doesn't work. It gives you an error if you try to do the for loop over an integer. But on the other hand, if it's a string, you could totally do that. So for number is equal to str number, right? Convert it to a string. Then for every digit in that number, which we converted to a string, we could take that digit and convert it back to an integer. Right? Convert the integer to a string, then convert this string into an integer. It's a bit, and that's how you could get that working. It's a bit, I find it inelegant personally, but it works. You get full credit for that. So let's go ahead and say, let's not do that. Okay. Instead, what we'll do is and I'm just going to comment that out so it's there, for number in nums, just like we did before. So now we need to go through each individual digit. Now, the way we go through and can get each digit in this product. Geez, issue with having long hair in the headphones is that they just always seem to get into the spaces you don't want them to get into on your face. All the spaces on your faces. All right, for number in nums, return product. So what we can do is that we can use math. Remember, modulo and integer division are nice tools for us to get individual digits. For the number, we can get, what we can say is that we can say, wow, number is greater than or equal to 0. So greater than 0, not equal to 0. While the number is greater than 0, what do we want to do? Last digit is equal to num per mod 10. That gets you the, so given a number, this gives you the last number of that digit. Sorry, the last digit of that number. It gives you the ones place of that number, right? Don't believe me, right? Let's go ahead and just show you again, right? How that works in idle. Just bring it up a console command, right? So, right, if my number is 345, if I mod it by 10, it gives me 5, right? The last digit. And then the other key is that if I do this, right, divide 10, integer division, that throws out the last digit. Right? We did this is all the way back in exam, during when we were first learning about for loops and while loops. So then we can say number is equal to number mod 10. So here we'll throw away that digit. So while the number is greater than 10, or while the number is greater than 0, get the last digit, throw away the last digit. And we should probably do something with that last digit, which is product. And then we can do times equals rather than plus equals. Times equals last digit. Does the same thing as this over here that we were doing. And let's go ahead and actually test this to make sure it works. That's one of the nice things about doing it this way, from at least if you're doing it on code, is that you can do it like this. Copy this, paste this over here, and let's go ahead and print. And hopefully I bet you there's going to be some crash somewhere from something completely else. No, apparently I did fine. So yeah, 192. Great. Okay, should have more confidence in myself. We should all have more confidence in ourselves. The hard thing to have when you program and everything is your fault. That's like the biggest issue with programming. Can't blame it on anybody else. All right. This one is one of those ones that I've loved giving as a practice problem. I've given it as a painful question on an exam. So this is a former exam question of mine. That's 231. I haven't been able to find out a better name for it. Given a list of numbers, return true if it follows the 231 pattern. Namely, that the list has the value x has a value x, followed by the value x plus 1, followed by the value x minus 1. X can be anything. It just needs to have that pattern where you've got x, x plus 1, x minus 1. So 1, 2, 3, 4, 5 doesn't work because it doesn't have anything, because it doesn't have that pattern. What does have that pattern? This one has that pattern, right? Because we've got a 3 and 3 plus 1. So we've got a 3 plus 1 in the 4, and a 3 minus 1 in the 2. 74 almost satisfies that. We've got a 3. So we've got, here's our 74, or 74 plus 1. And the 73 would have satisfied it over there. But it only has to have it once. It only has to have a pattern like this once. Make sense? And then over here, we've got 74, 75, 0. Then we've got 1, -1. Sorry, we've got 0, 1, -1. That satisfies that pattern. All right. And the R, that's just a holdover for when I gave this in Java. That's how old this problem is. We used to do Java as the intro programming language. Okay. R is just what we would call an array. So let's just call it nums again. Boom. Okay. Okay. And what we're going to do is that we're going to assume that it does not have the pattern, right? By default, it does not have the pattern, but as soon as we detect this pattern, we'll return true. Okay, so for nums, so this will go through a few, about one rewrite. Okay, for number, oh, well, we're looking at x, so for x in nums. Normally, I discourage you using a value like x, but x plus 1 and x minus 1 makes sense. All right, so for each number, for every number, okay, I need to know if the number after it is equal to x plus 1 and the number 2 after it is equal to x plus 1. Oh, no, right? Oh, no, I have to iterate through this, which means that I have to care about the indexes, because if I'm, sorry, specifically I care about the indexes when I'm iterating through this now, because I need to not just look at the number I'm currently at, but the number after that I'm currently at, the number to the right, which is plus 1, and the number to the right of that, which is plus 2. All right, so what do I have to do? Well, in that case, I have to do either this, I have to change it like this, for index in range, length of numbers. Then you say x is equal to nums index, right? Hopefully you've seen that a number of times. Personally, I'm more of a fan of using what's built into Python, though, which gets me both, which I can do to get me both of those at the same time, which is for, let's see. For index x in enumerate, and then nums. Okay. We can do that. So that's our first rewrite. Either this, that's the shorter way to do it. I'm going to go do it this way, though, because of just it's simpler in some ways. So this iterates over all the indexes from 0. In this case, it goes over in the indexes 0, 1, 2, 3, 4. Indexes 0, 1, 2, 3, 4, 5, 6, right? So so we go get our index, there's our x. So for every index, we get the value x. If x is, so here's it's kind of weird to phrase, right? So we need to check the next one. So if nums at index plus 1 is equal to x plus 1, right? That's such a weird way to phrase it. It's exactly what we need, but you have to like think about how to phrase it, right? So if the index after me is equal to x plus 1, right? That's what the problem specifies. It has the value in the list, followed by the value, sorry, it has the value in the list, followed by the value plus 1. And then there's another clause, right? There's two things we have to check. Let's go ahead and put this into parentheses, not because we need it, but because it makes it, I feel, a bit easier to read. So this, if nums index plus 1, if the value after x is equal to x plus 1, and the value 2 after x plus 2 is equal to, in this case, it's x minus 1, because we're doing that whole pattern, x minus 1, where it's, we've got, right, 3, 4, 2, 3 plus 1, 3 minus 1. And we'll go ahead and put that into parentheses as well. Not that we need to, it just simply makes it nice and clear. So if those two values are true, then it follows that, then we found something that follows that pattern, and that's actually the entire problem. If you're satisfied with getting 7 out of 10 points, that is. Because there's an issue, right? I mean, and you'll go like Professor Rosen. No, I'm going to just copy this here, right? You gave me code to test. Yes, but I didn't give you good tests. It's the issue. Print. Okay, true. Great. Awesome. So now let's go ahead and test it on 1, 2, 3, 4, 5 on the other. Actually, so I did give you a good test. 1, 2, 3, 4, 5. We get a list index out of range issue. Okay. Why? Well, because we start at 1, we look at 2 and 3. We start, that doesn't fit the pattern. We look at 2. We start at 2, then we go to 2. We look at 3 and 4. That doesn't fit the pattern. We go to 3. 3 fits the 3 and 4 fits the pattern, but 3, 4, 5 does not. Oops. Then we go to 4. 4 and 5. Well, that fits the first part of the pattern, but 4 and 5, and then 4 index 3 plus 2 is index 5. There is no index 5 here. We're out of bounds. So remember, whenever you're iterating something and having to look ahead, we need to make sure that our that we aren't going to go through. So if we're going to be looking 1 ahead, we'd want to iterate 1 less, and if we're looking 2 ahead, we iterate 2 less, and that will solve that. You can also there's other ways to do that. You can also be a bit more, how to say it? I mean, that's the preferred way to do that, but there's nothing stopping you from doing something like this. If index is less than len nums minus 2, right? We could do that to make sure that it doesn't go out of bounds. All right, we can make sure that doesn't go out of bounds, just blocking it like that. We could also not indent it and simply do this. Continue is a special word. It just means continue. It's like an almost break, right? Break stops a loop. This says, well, don't break, just stop this iteration of the loop and go on to the next one. I don't really use it too much. I feel you only really need to use it if you don't really want to refactor a bunch of if statements. There we go. So we could do that. But as you can see, it's much cleaner just to simply say, the index, I'm only going to go and iterate through these, and index is only going to go up to here, and index is only going to go up to here, because I'm going to look up to 2 ahead. Right? Yeah. So, okay. Okay, so we've went over this one. This was a problem for the second practice exam that I moved from a final exam practice problem to that. Same with the monopoly. So let's look at one there. Right. Oh yeah, there we go. Given a letter. Wonderful. Given a string, write a function that contains the most common words. Right? This is a dictionary problem. So that's what we were missing. Right? And they're generally the dictionary problems are generally the same as they have been. Given a string, write a function that contains the most common letter in a string. So let's go ahead and given a string, find the most common letter. Letter. All right. And the way we do that is we have our results equal for our counts. We set that equal to an empty dictionary. Here's our text or letter in text, right? And it's asking for the most common letter in the string. And we can assume that we don't care about spaces or something like that. We can figure out how to deal with spaces later. I mean, we can skip over spaces fairly easily. Letter. If you really cared about actual letters, though, like it says, we would do some, which I wouldn't on a test. We can say if letter alpha. But we really don't need that. So for letter in text, if letter in counts, let's go with not in. So if we've not counted this letter before, right? So we go through letter by letter. If we've not seen the letter before, well, we've seen it once now. Counts is equal to 1. Counts of that letter. What? Else we have seen it before, in which case counts of that letter is equal to counts of that letter plus 1. You could easily just do plus equals 1 over there, right? We could just do plus equals 1 as well. Okay. And again, so there we go. So that's how we just count up how often each one occurs. Okay. But now we need to find out which is the most common one. Okay. To do that, we say for letter in counts. Now we go over through here. This goes automatically through the keys. And we say let's go with appearances. Or we'll just simply say C is equal to counts. Letter. C is equal to the number of times that letter appeared. Okay. Appearances was a bit long to type. So we get C for that letter. And we say if C is greater than the most we've seen, the most common letter we've seen so far. So we'll need to keep track. We'll have to keep track of that. Letter. And highest count. So if C is greater than our highest count, then highest count is equal to C. Most common letter is equal to our letter, right? If we've seen this more than what we've seen before, this becomes our most common letter. And then what do we do at the end? We were asking for what the most common letter was, so we just simply return it. Any questions on that? Although what I should do is I should probably, because I accidentally named them the same thing as my function, so let's not do that. Okay. Now to get into the meat of today's lecture. Oh, actually, one more problem. There was one problem there I saw, which was given two strings, write a method that returns true if they are permutations of each other. Two strings are permutations of each other if they each have the same numbers of each character. Use a pair of dictionaries to do this. This is a much harder problem than what would appear on the exam. Okay, so we have two words, word one and word two. This is the number of times that would appear in one. I'm giving you this kind of idea. And I give you basically, it's a hard enough problem that I tell you is a hard problem. And I give you two lines of code to go, which is basically, we've got count one and count two. What are they counting? Here for count one, this is keys are each character that appears in word one. Value is the counts of each character in word one. Same but word two. There we go. So we count how many times. So what we're going to do is we're going to go through word one, count how many times it appears, and go through word two and count how many times it appears using dictionaries. Okay. You can do this without dictionaries. It's just the loop looks horrible if you do it without dictionaries. Okay. And it's the same kind of thing. So for it, like you have a loop and then you loop through the same thing as a nested loop. It looks horrible if you do it without. And I make the 2168 students do this without dictionaries or hash maps as part of an assignment. Okay. So what's an example of a word that might be like this? Right. Wolf and flow are palindromes of each other. Or sorry, is permutations of each other. Right? They have the same exact letters. But let's for an abstract example, ABBA and AABB, those are permutations, but AAAB and AABB, these are not permutations because we have 3 A's versus 2 A's. Make sense to everybody now? Okay, so we're going to assume it's a permutation until it's not. Okay, that was weird. Turn true. And there's one thing we can do to speed up this process. That's going to be very helpful. If len of word one is not equal to len of word two, turn false. They're not the same size, then they can't be permutations of each other. They just can't be. Think about it for like 10 seconds. Right. All right, so let's go ahead for a letter in word one. It works exactly the same way. If letter not in word one, if we've not seen it before, so not in counts one. Of course it would be. If word not in count one, so if we haven't counted this letter yet, we count it now. Else count. Geez, really good job with the typing today, Andrew. Count letter plus equals 1. Okay, then we do the exact same thing, but for word two to get our counts of each other. So I'll count 1 for word one, and so I'll count 2 for word two. Right, so we count them up for count 1, we count them up for count 2 for word two. Now we just need to make sure that they occur the exact same number of times. So ideally, I would love to. I'm not sure if this would work, by the way. Ideally, what I should be able to do here is I would love to say instead, if count 1 equals count two, but I don't know how Python checks to see if two dictionaries are equal off the top of my head. So we'll have to just do it manually, which is as follows. Which is just simply go through all the letters in word one, or all the letters in count one. For letter in count one, if count one letter not equal to count two letter, return false. Basically, we look at every letter in count one and look it up, and we say, hey, has this appeared every time, each time? Has, you know, sorry, we look at every letter that we've counted for the word one, and we say, hey, if I have the same number of counts as I did in word one and the same number of counts I did in word two, that's great. But if there's a mismatch, they can't be permutations, right? Because because they have different amounts of the same letter. Okay, and that's it. That's all I need actually to check. Why? Why don't I have to check for letter in count two? Why don't I have to check that? Because it's a bit of logic. I'll let you think about it yourself, figure out yourself, but it has to do with the fact that this allows this assumption over here that they're both going to be the same length, allows me to assume that I can only have to check one way, because because they'll have a mismatch otherwise. Okay. There's no way to create a string that would trick it. All right. So let's go over yeah, let's go ahead and skip that for right now. We'll go over the regular expressions first. Okay. Regular expression. So all the regular expression problems always look like this on the exam. So if you spend the 2 hours to learn how regular expressions work, you'll get a question that looks like this. Write a function that, given a file name, creates a new file with the exact same contents as the original file, but all of the something are replaced with private. A couple of years ago, I did it as TU email addresses, right? Anything that was, remove anything that was TU, TU letter, something at, temple.edu. I said, remove that. Make sense? So another semester, if I hadn't been, it was social security numbers before I used that as the example in class. It's the same exact thing. The only difference is what regex we're going to be using. It's always going to look like this. Okay. So before we figure out what that thing is, it's always going to look like this. Def regex problem, file name, right? So it's always going to look like this. What the first thing I have to do is that I need to read the file. Open. File name. And the file is equal to, open that up. And then this is actually one of the few times where we actually use read. Before I forget, import RE. Okay. For regular expression, that's our regular expression library. This is one of the few times where we will just simply say, we'll simply say, sorry, what we'll say is something along the lines of the file dot read as opposed to read lines. We want to get all of the text dumped in, we want all the text in the file dumped into this a single string. No need to iterate line by line because we're just going to do it all in one go. Okay. So that's part one, where we have to read the file, right? With the exact same contents. Create a new file with the exact same contents. So let's do that. Create a new file with the exact same contents before we start replacing. Okay, how do I create a file with the exact same contents? Output file is equal to open, and let's give it a name. Maybe problem two. Let's go with maybe problem regex.txt. But you can name it whatever you want. In fact, actually, why don't we go ahead and leave that to the user? Output file name. There, I don't have to worry about it. Now, not my problem. When to use read and when to use read line. Read in a case like this, where as you'll see, what we're going to do is we're going to just simply go through the file in one go. No need to use a for loop to iterate through it line by line. You use read line when you want to iterate through it line by line. You'll see that this is basically the only occasion where we're just going to use .read. Okay. So you're only going to use it .read in this regex problem in terms of this class. So, okay. So to write a file, we'll just simply say output file name .write, and then okay. And what we're going to need at some point is output text. For right now, output text is just going to be equal to text. Right? And what we're going to do is we would say, okay, here's your output file. Right. And then we would say output file dot write output text, because we can just simply do it in all one go. Output file dot close. And that's how you write. That's it. Rather than printing, you just simply say output dot write. Output file dot write. That's it. So this is always, so these three lines are always going to be the same. These two lines are essentially always going to be the same in the regex problem. Okay. And finally, well, the last thing that's always going to be the same is going to be output text is equal to re.sub. Right? If you go through, if you watch the regex video I posted last week, re.sub pattern, which we haven't declared yet. I'll do so. Pattern text. And what's the other one? So pattern removed or private or whatever. And then text. Pattern is equal to okay. So why did I do it like this? Okay. So first off, reading a file and outputting a file. This is going to be same for the regex problem no matter what. Okay. Next, what does re.sub do? It says, given a pattern, regular expressions define patterns of text. Okay, that's what regular expressions do. They define patterns of text. So given a pattern, replace all instances of that pattern with removed. And where are we, and what are we doing it to? We're doing it to text. So if you see this pattern, replace it. If you see this pattern in text, replace it with removed. That's what it said. That's what this says. Okay. And depending on the problem, I might tell you to replace it with something like private or removed or censored or deleted. It doesn't matter. I'm not going to tell you, it's not going to be something variable. Okay. There's actually a lot of power you have over here to change that. So the only thing in this entire problem, in this entire answer that changes for the exam is this right here. That is the only thing that changes for this exam. I'm giving you a big hint here. That's all that you need. In other words, you put this all down, you're going to get partial credit, right? It's not that. It's a very easy way to get partial credit if you're stuck. But the pattern, that's where the bulk of the points will be here, because this is always the same. This is always the same. This is pretty much always the same. But this thing over here, that's basically the only line you have to do in this problem, which can be worth like 15 points. It's the only line that matters, and the only string that matters. Okay, so what we're trying to do is so what are we actually trying to do here? Write a function that, given a file name, keeps the new file with the exact same contents as the original file. Okay, we did that, but with all the phone numbers, US phone numbers, by the way, such as open parentheses 1, 2, 3, close parentheses 456-7890. And if that's your phone number, sorry for doxing you, replace with the string private. All right. It's not actually how doxing works, but you know. So we want phone numbers. Now, on the exam, I'm a bit more exact about it, and let's say that assume that all US phone numbers are something like this. Space. All US phone numbers follow this pattern. All right. Let's go ahead and assume all US phone numbers solve that pattern. So over here, what you do for the answer is you'd say we have a open parentheses and a closed parentheses. Because with a regular expression, those have special meanings, so we have to escape them. Actually, let's forget about the parentheses for just a second. We'll ignore the parentheses for just a second and just focus on this. Let's pretend that these parentheses don't exist for just a second. Why? Just to make it easier on you for right now. Right? Okay. So let's go ahead and do this. So let's assume a phone number looks like this. It's number, space, 3 numbers, dash, 4 numbers. So this regular expression for a number, as it says on your practice exam, is that. That's a number. And second number, and a third number, followed by a space, followed by 3 more numbers, followed by a dash, followed by 4 more numbers. Okay. Now I can shorten this, okay? If this makes your eyes water, we can shorten this. 4 numbers, 3 numbers. Right? So if you remember from my video, if you watched it, this means some number, 3 of the preceding thing. So 3 numbers, followed by a space, 3 numbers, dash, 4 numbers. Make sense, everybody? Okay. Now let's worry about parentheses. To do a parentheses, we do slash open parenthesis, slash close parenthesis. That's it. Okay. But Professor Rosen, you ask. I go, what? What if we have to do both? Well, that's a great question. There's 2 ways to go about doing both. First, if it's easy enough, there's some ways you can specify that a character is optional. For instance, we can specify that the open parentheses is optional with a question mark that says 1 or 0 of the preceding. But another way to do that, if there's something a bit more brute, if there's something else we need to do, say we've got 2 variations we're looking for, we can use a single bar for or. And we could just simply say we're looking for it with the parentheses or without the parentheses. And I'll put those in, and I'll put these 2 things in parentheses. That's what the parentheses are to, just to let the computer know that these are a whole expression unto themselves. Okay. Now, how would this work if I was looking for something else? Say what I had a couple semesters ago, which was some email address that looks like this. Suppose I want to remove only all TUID numbers. such as mine, TUG 85861 at temple.edu. So I want to remove everything that looks like this, but neither of these. That's my Gmail address. It's my personal Gmail address for when I'm just using stuff that I don't want to be sent to Temple. And then also there's my other, the Temple address that you actually used to email me, which is just an alias for the first one, right? So, right, and be sure you get yourself your own alias, right? You should go through the Cherry and White directory and set up your own alias. It looks a lot more professional. And I think as a student, you're allowed at least one. It's also an easy way to make it if you have a preferred name change, to make that preferred name change, right? For me, I think as a faculty member, I get 5 aliases. I'm not sure how many students get. So, we made the mistake of claiming Rosen at temple.edu. So all the other professors, sometimes I get stuff from meant for other professors who are named Rosen, which is inconvenient. I've gotten a number of lacrosse invitations. Very interesting. Anyway, so suppose you've got this. We want to remove this over here. So the way I look at this email address has 2 parts. Everything before the @ and everything after the @ Okay. Everything after, so let's go ahead and work on the back end first, right? Let's assume that the pattern, again, all we're changing is the pattern. So we have an @ here. Okay, we need all the stuff before the @ and all the stuff after the @ All the stuff after the @ is always going to be the same, right? It's temple.edu. Although, to be clear, even though this will work, dot in regular expressions is the wildcard character. It matches anything. So escape that if you want a literal dot. Again, spending 2 hours learning regular expressions. And it is not in the textbook, it's not in the primary textbook. Where can you find it? Where can you find all this stuff? It's in the other textbook listed in the syllabus, free textbook. Automate the Boring Stuff has an entire chapter on pattern matching with regular expressions. And the reason that I linked this textbook is because of this chapter, and the reason that this chapter is even useful is because this is very useful if this is the only programming class you take. Regular expressions are supported by everything. Watch, Control F. Okay, look at that symbol over here, right? It's got the find character. It's a bit hard to see on your screen maybe, so you may want to zoom in at some point. So here, it's a find replace dialog. Look at this. It says use regular expression. Boom. And suddenly now everything that now I can search for a regular expression. I can look for any 3-digit sequence by looking for this /d/d/d in there. It supports that regular expression. I'm pretty sure you can. I'm sure the Microsoft Office apps at this point have it built in. It's a very useful tool. Okay. And again, it's super easy of points on the final exam. Okay. At temple.edu. So that's all we need for this part. Then we have this part over here. That's fairly straightforward. That's 5 numbers, right? /d 5. And then we have okay. So the email addresses for this are always what? They're always TU something. They're always something. TU something. Right? So TU, and then I'm not sure what the rules are. Let's say any lowercase letter. So here I'll say any letter. So this means one of A, B, C, D, E, F, G, H, I, J, K, L. It's really ridiculous to have to do that, right? So we don't do that. Instead, we just simply, but this would say, hey, this would match TU A and 5 numbers. This would match TUB and 5 numbers, TUC, TUD, TUE, but none of the other ones. If I want to match all the letters from A to Z, I can just simply say A through Z. That's what the brackets do. how many questions will be on the final exam? I'm not sure. Probably around 10. But of those, you'll definitely be able to choose. One section will be a subset, like choose some subset. I'm not sure how many are going to be into choose a subset yet. Okay. Like I've still got to write it because I'm adjusting it from being an online final, or rather not an online, but an electronic final. And the reason being is that it's just become too easy to cheat now with using ChatGPT or plugins like GitHub Copilot, which is amazingly good at doing this kind of stuff. So, you know, the AI has just basically made it so that cheating can be done very quickly. An extra slash in the previous pattern where over here. This one? Nah, this one. Oh yeah, there is this extra slash right there. I forgot because remember what I know how that happened. Remember I was doing before I had that, I had /d/d/d, right? So I just simply didn't delete enough when I did that. That's what happened there. Thank you. Good eyes, everybody. That I didn't make a mistake. I was just testing you. That's my story, and I'm sticking to it. So let's see. All right, so TU A through Z /D 5 at temple.edu. And that's it. That's all we need. So we are done with this problem. So again, this is a very valuable tool here to learn. And it will just only remove TU at Temple emails. It's not going to remove my Andrew.rosen at temple.edu, nor is it going to remove the Professor Andrew Rosen Temple email address. Isn't that wonderful? Okay. Next problem is Monte Carlo. Now, any kind of thing, this I gave as a final exam problem, and I personally don't think it went too badly 1 year's the final, but it certainly was. It had a number of questions I had to answer for students, unfortunately. I mean, so here's the Monte Carlo problem that was on a few years ago. Dungeons and Dragons, D&D for short. Big fan. I actually I DM'd the entire Curse of Strahd campaign from start to finish for a group. Dungeons and Dragons, D&D for short, is one of the most popular tabletop role-playing games currently on the market, if not the most popular, and I happen to be a fan. In D&D, players take on the role of adventurers. For your exam, we will be running a simulation to answer the following question. What are the odds a level 1 fighter, so a player who's just starting out as one of the easier classes, one of the easier roles in the game to play, what are the odds you can slay a goblin 1 hit? Okay. So what do we need to know to answer this question? Dice. So goblins are very straightforward kind of enemies in D&D, very, very, very common, but they're also very dangerous if you're not careful. Just because they are meant for first level adventurers doesn't mean they're not dangerous. All right. So first, Dungeons and Dragons use dice to determine the outcome of any action that has an element of chance, such as whether you hit something or not, or how much damage you do, or did I successfully leap over that chasm? Anything, and you only really roll if it has dramatic effect. So, yep, it is exactly Baldur's Gate. So these dice range in size, but for our exam, we only need to concern ourselves with 2 types of dice. The 20-sided die, a D20, and the standard D6-sided die, a D6. Dungeons and Dragons uses dice notation, which is a very popular notation for D&D for rolling things. There's your standard die is, your standard cube is what we refer to as a D6 because it is dice with 6-sided. For Dungeons and Dragons or Baldur's Gate or anything, these kinds of games that are based on the D20 system, they use a 20-sided die, a D20. Rolls look like this. 1 D20 plus 5, take a 20-sided die, roll it, add 5 to the result. So that means you would roll the 20-sided die, whatever number it landed on, you'd add 5 to it. That's what the +5 means. If it was 1d20 + 4, you'd add 4 to it. If it was 1d20 + 3, you'd take a random number from 1 to 20, add 3 to it. Because we're adding 5 to it, this gives us the range of 1 to, and that should be 6 to 25. 6 to 25. Why? Because 20 is the highest value we can get on this. And 6 is the lowest, because the lowest you can roll on a dice is a 1. Here's another one. 3d6 + 4. Take 3 4-sided dice. They're little, those things are typically little caltrops. They hurt more than Legos to step on. Okay. 3d4 + 4. We roll 3 4-sided dice, that meaning each of those has a random value of 1 through 4. Add 4 to our answer. That gives the range of 7 to 16. How do we get that? Well, the lowest you can roll on each of those is a 1. So 1 + 1 + 1 + 4. 1 + 1 + 1 is 3. 3 + 4 is 7. There we go. That's our low range. And then getting 4 on all 3 of these dice is 3 4s. Add 4, that's 4 4s. And then this one's a fairly fun roll to do. That's a fireball, 8d6. Take 8 6-sided dice, roll them up, sum them up without any, roll them, sum up without adding anything. So what we're going to be simulating is, so that's the dice notation. So hopefully with those examples, everybody kind of understands when I say roll a d20 now, okay? Okay, the way combat works is in 2 parts: attack roll and damage roll. So to see if attacking something is, you've got 2 rolls to do. One, you first see if you hit, then you see how much you hit it for. How hard did you hit it? So the attack roll is made to see if it hits the target. That's the first roll we do to make sure if we see we hit. It's done by rolling a d20 and adding a single number called the attack bonus. The number needs to be greater or equal to the AC. In other words, we just need to make sure the number we're rolling, the d20 plus the added number, is more than some target. And that typically indicates how tough the monster is to hit. If attack hits the target by meeting or beating the AC, we make a damage roll to see how strong the attack was. If it misses, which happens if the attack roll is lower, we don't make a damage roll. So we effectively roll 0 on damage. So examples of how that works. If I've got a wizard trying to blast a zombie with fire, zombies can't dodge well because they're shambling evil undead. They have an AC of 8. So assuming my wizard's attack bonus is 4, I would roll a 1d20 + 4. So I'd hit it so long as I roll a 4 or more, right? 4 + 4 would be 8. So as long as I rolled a 4 or more, I'd hit it. If I roll lower, I miss. If I hit it though, I can move to the next step and roll for damage. Rolling for damage is much simpler. You just simply roll a die. No need to compare it to anything else. Unless you're playing on 3.5 rules, which we are not doing. Those rules were broken. Okay, anyway, so when our attack hits, we roll for damage. That's much simpler. We simply roll the die and add the bonus. So say you're a cleric who hits a ghoul, another type of kind of super zombie. So say you hit a ghoul with your mace, you do 1d6 + 2 damage. That has a range of 3 to 8. While the wizard from the example above, if it hits if you blast that zombie with fire, you might deal 1d10 damage. The damage is subtracted from the target's HP or hit points. If we reduce the target's HP to 0 or less, we have slain it. So attack roll, damage roll. So we're going to simulate a level 1 fighter, a player who just started the game under one of the most standard classes to play, but by no means the weakest, attacking a goblin and calculate the odds of the goblin slaying the goblin in a single strike. Sorry, I keep rereading this problem and keep thinking Goblin Slayer. That's all. So a fighter's attack roll is 1d20 + 5, and the goblin's AC is 15 because they are quick and they wear armor. If the attack roll hits, then we're going to do 2d6 + 3. A goblin has 7 hit points. And in case you're wondering, if you do play D&D, in case you're wondering how this is calculated, it's just a fighter with a great sword with a strength of 16 or more, and he is taking, and for simplicity's sake, he's taking the defense fighting style. So calculate the odds of a fighter slaying a goblin in a single blow by simulating 100,000 attack rolls and calculating the respective damage. A miss roll is 0. Rubric. Roll code for D20, code for D6, code to make an attack roll, code to see if the attack roll hits, code to calculate damage, code to see if the goblin's slain. So, first step first. Let's get those dice rolls in. Right? And this was and again, would I give you one with this many rules? I mean, if there was only a few problems, right? That's again, it was one of those instances where we could select something. The question I give you again for the Monte Carlo the question I give you for Monte Carlo on the exam is much cheaper. It's literally a game made for toddlers. So, okay. So let's go ahead. We need to go and import random. Okay. Def D20. To roll D20, we'll just simply return random integer 1 to 20. And to roll a D6, turn random rand int 1 to 6. Unfortunately, no, I've not played Baldur's Gate 3 yet. I have not had time. I haven't really even had time for tabletop D&D, and I'm hoping to do that over the summer. Like I said, I did run the Curse of Strahd campaign, and that's a vampire-based one, and I was so happy because I was able to get that to finish up on basically the weekend of Halloween. So that was pretty good. It was a very good campaign. Yeah. Let's see. So we've got our dice rolls now. Okay. Now, the first thing we need to do is we need to write a function. We've got these two functions, attack roll and damage roll. We need to see if we can hit it, and then we see how hard we hit it. So def attack target. Right, and we know what our target's going to be. It's going to be 15, but again, I'm just making this generic. So what we do to attack is that we are going to say, okay, our roll. So let's see. So the attack roll, the roll we make to see if we hit the target is the attack roll. And our roll here is 1d20 plus 5. You don't have to know how I made that, got there. That's D&D rules. All you have to know is how to actually physically roll those dice. 1d20 plus 5. So our roll is equal to 1d20 plus 5. If roll is greater than or equal to the target, then that's a hit. Return true. Else return false, but actually I'll just skip that step and simply do return roll is greater than or equal to the target. That's it. That's all you need to do to see if you hit. Just roll that number, generate that random number, and then see if it's greater than the target or equal to the target. Def damage. Okay. Fighter's damage roll is 2d6 plus 3. So return. And I can't just say 2d6 because that's not a function I wrote. Instead, I'll say d6 plus d6 plus 3. Making sure I'm not getting an emergency. Okay. d6 plus d6 plus 3. And then, okay. And then code to, so here we go, code to make an attack roll. Boom, made the attack roll. Code to, or function to calculate the to see if it hits. There we go. Code to calculate the damage, did so. Death. Code to, or function to see if a goblin is slain. Death. No, let's go ahead and do this. Death. Fight goblin. Or let's. Okay. Okay. If attack 15, so we're making our attack roll. Let's go ahead and actually change this to attack roll. So that if you're, when you're going through, it matches up a bit easier. If attack roll goblin AC is equal to 15. If attack roll and on the goblin ace armor class is, that's the target number we're trying to hit, is equal to true, then we hit. And then we have to do the, so if we hit, great. Otherwise, we did not slay the goblin, so I'll say return false. So I'll say return true if we did slay the goblin, and in one shot, and I'll say return false. Oops. False for slaying the goblin, return true if I did hit the goblin, if I did slay it. So if it hit, so here I say attack the goblin. If I hit it, great. If I hit it, then what do I need to do? I need to do the second part, which is calculating damage. Damage roll. Damage roll is greater than what number? Goblin has 7 hit points, so I need to do 7 points or more damage to it. So 7. The damage roll is greater than or equal to 7. Let's go ahead and say goblin HP rather than leaving magic numbers in there. Return true. Now, the entire point of this goal of this is, can we kill a goblin in one shot? Or can this fighter kill the goblin? What are the odds of the of this first level player killing a goblin in one shot? And we want it to be, actually, if I'm a game designer, I want it to be fairly high for the fighter to make combat exciting and rewarding. Make them, not feel like they fell into a trap by not picking the objectively best class, the bard. Okay. So, all right, so I'm surprised I didn't get any pushback from that one. Okay, so trials is equal to 100,000. I'm going to do 100,000 of these for in range. Zero for blank in range. Trials, so we're going to do 100,000 of these. If fight goblin equals true, turn wins plus equals 1. And then print wins divided by trials. And there we go. True. They can't divide by true. And the answer is 50.358. So it's actually pretty good. It's not what I would have thought it would be, because it seems like you only have a slightly better than half chance of hitting the goblin in the first place. Because you have to roll, let's see what you have to roll. You have to roll a 10 or better to hit it. Right? So you only got a 55% chance of hitting it in the first place. But actually it ends up being not too bad of chances. as it turns out. Right? Okay, so that's a Monte Carlo problem. Okay, so administrative stuff with regards to this end of semester stuff. First off, if you're emailing me because you haven't done any work all semester, time to do that was probably a few weeks ago. If you've been doing work all semester though, and just haven't had the chance to demo it, and you've been showing up to your labs and stuff, just reach out to your TA, send them an email, and have them and arrange time for them to demo your work for them over Zoom, if for some reason you haven't. For your final project, remember I went over that during the last class. Please submit it, please keep your video to 3 minutes so I can go through them all on Tuesday. Hopefully I'm maybe a bit tricky because I'm going to have jury duty on Monday, potentially. And if I'm not excused from it, I might have to be in the jury on Tuesday, which means I have to wait until the evening to do all these. So please definitely keep these in 3 minute range so I can find out who the best projects are. Otherwise, I might have to rely on my TAs, in which case they will give me a short list of what the best projects are. So let's see. So again, just simply submit that. Only one person needs to submit the link, but if otherwise, just let me know who the project members were. How'd you contact? Email. Contact your TAs via email. Now, with regards to the Runestone stuff, my plan is to run the grader tonight and update the grades. So again, just get those in by sometime after I give out the final. That's going to be, I'm going to run the grader for the last time, but I'm going to run the grader, essentially starting now. How many best projects are you picking? I typically pick at least one from each section. So one best project from each section. That means potentially, if there's 3 people in a project, then all 3 people are excused from the final. And so I think a total of maybe 14 people got excused last semester and 12 the semester before that. Okay. Finally, curve. How does the curve for my class work? In general, you need a 70 or above to pass. It only allows one. Add the second URL as a comment. Add this as the second URL as a comment. Or have the link in the GitHub, or have the second link in the GitHub repository. So the curve, how does that work? Right, as stated in the syllabus, doesn't matter what the curve is. If you get a 90 or above, you're getting an A. If you get an 80 or above, you get a B. Not B minus, B. If you get a 90 or above, you get an A, not an A minus. If you get a 70 or above, you're getting a C, not a C minus. Okay, I don't really do C minuses too much. I try to avoid those actually, because some universities have rules about C minuses not being good enough. So, next, as long as you've, well, so here's the thing: you should have had your demos done a while ago because they were because it's been, the last time was due mid-month. But regardless, if you still have to demo the last one, just arrange with your TA. They've got to be done before. Please try to get them done before the final. Okay. Not by the end of today, because technically end of classes is on Monday. So, just reach out to your TAs, and you can arrange to have them. It would be easiest to arrange to demo them over to demo them over Zoom. Okay. If you're on a Mac and you haven't demoed over Zoom before, you may have to, enable some permissions when you share your screen, and which will make you need to quit and then rejoin. So just be aware of that. So going back to what I was saying, so curve, right? So the way it works is I will take the final grades and I will sort them from highest to lowest. I'm not going to look at any names. I'm just going to sort them from highest to lowest, and I look for a breakpoint. So I'll look typically and say, okay, there's not really much of a difference too much between a 90.1 and an 89.9. Oh, the next lowest grade is an 89.7. Next lowest one is an 89.6, 89.5, 89.3, 89.2, 88, I'm sorry, 88.9, 88.7. And then I typically see around, and then this is what I saw last month. So 88.7, 87.2. So we went from having tenths of a point of a grade to, do you have to do all the projects on Runestone? No, you only have to do the things that are on the assignments tab and the things I did in class. Okay. So that's why I'm going to run it today, just that way you can know what you're missing. Okay. But if you've been following along with class and following along with assignments, it'll be fine. So anyway, last semester, the cutoff for an A-. So once I'll answer your question a bit in a second, Brock. So what I do is I look through last semester, what it was is that everybody who got above a 90 or above got an A, and if you had an 88.5 or above, you got an A-. And that's typically the way it works. Basically, basically I don't like dealing with students asking me to bump their grade up, generally speaking. What I do is I just go ahead and bump it up for you using the minuses. If I feel like there's not much of a difference. Yes, Abrar, what's your question?
So, Professor, something's like wrong with my VS Code, and it isn't can I like share my screen and show it to you?
After class. Okay.
Or,
After I'm done here.
or,
Yeah, once I'm not recording anymore. Okay. Any other questions before you go? The class is dismissed otherwise. No? Okay. Bye. I'll see you during the final exam. Good luck.